interpreting graphs of motion. So I've done videos before on how to go between displacement time, velocity time, and acceleration time graphs. But I wanted to make a video on how to actually interpret graphs. So with interpreting graphs, it's nice to always write down the formulas first, or go to the formula sheet if you're sitting in an exam. Sitting in an exam, there's a formula sheet at the back, hopefully. So here are the formulas, common formulas. There's speed equals distance over time. There's velocity is displacement over time. And there's acceleration. Oh, there's this actually. Okay, there are these three formulas hopefully given on the formula sheet. What do they mean? Well, typically, so the first one, V equals D over T. Sometimes S is used, but V is typically used. V is speed. It's a measure of how fast you're going, how much ground, how much distance D you're covering in a certain amount of time T. Think of your speedometer, 50 k's per hour. That's a speed. That's a measure of speed. Distance here and time here. The next one here is velocity. This is essentially speed, but with a direction. The arrow on top, whenever you see an arrow on top of a symbol in maths or physics, the arrow means vector. And a vector is anything that has size or magnitude, as we call it, size and direction. For example, just look up on your phone, the weather app, let's say wind speed 10 k's per hour northeast. That is a vector. Or if you're on an airplane, landing at an airport, and the captain comes on and says there's a strong gust of winds coming in, 50 k's per hour northwest or something, that's a vector as well. And so vectors are very common and widespread, they're used everywhere. But velocity is essentially speed, same thing as speed, but with a direction. And S with an arrow on top, this is displacement. Displacement is how far you are from your starting point. And T is time as usual. Now here's a little hack for you. If you don't really know the formula for acceleration, that's okay. The exam formula sheet will have this. What you can do is rearrange for A, acceleration. So V is the final velocity. U is the initial velocity. T is time. So take this guy over first. That becomes a minus. So V minus U is AT. To get A by itself, you divide both sides by T. T's cancel here. So A, acceleration, is just the change in velocity, which is the numerator, delta V over T, the denominator. Okay, V minus U, final minus initial. This is what you need to work with. First, understand these, understand them really well, then go into graphs and learn how to understand graphs. So let's go to graphs. I'm going to start with a displacement time graph, or distance time graph. In this case, will be the same thing really. Displacement, so S, put S arrow on top, displacement versus time graph. Okay, displacement is S with an arrow on top. Now I'll write half an arrow. You can write half an arrow in physics, doesn't matter. But in this case, I'll write a full arrow for you, T. Suppose you have a graph like this. Okay, so suppose you have two axes like this. Suppose you have a graph like this. What the hell does this mean? Well, when you see a flat line, the best way to interpret this is to picture someone doing something. So if this is, let's say, at 50 meters, okay, that's 0 down there. Doesn't matter about the time for now. A flat line, what does this mean? This means you are not moving. So let's say this is, this goes over, 10 minutes. This means you are not moving for 10 minutes. You're stuck at 50 meters. You're standing still for 10 minutes. You're at 50 meters. You're at the 50 meter mark away from your starting point, the origin, 0 meters. You're 50 meters away. You're just standing there. That's what this means. You are stationary. A flat line where there's no slope, no gradient means you're stationary. So that's a common scenario they can give you. Interpret this graph. So that's what that means. Let me give you another scenario. So once again, imagine someone doing something. Suppose you have a graph like this. Okay, a linear trend. Okay, a slope. There's a line with a slope. What does this mean? This means you are moving at constant velocity. You're moving at the same speed, same rate, in a particular direction. Okay, you're moving away from the origin in this case. So let's say this goes up by, I don't know, 2, 4, 6. You could be running in this case, marathon runner, 2, 4, 6 meters per second. 2 meters, 4 meters, 6 meters, at 1 minute, 2 minutes, 3 minutes, or just an average person actually. It doesn't have to be a marathon run in this case. If you look here, the trend, okay, it's a constant trend, okay? So after 1 minute, let's say, he's walked 2 meters. After 2 minutes, he's walked 4 meters. After 3 minutes, 6 meters. So there's a linear trend, as you can see here. Numbers are going up at a constant rate. This is constant velocity. Okay, someone's walking at a constant rate. Another graph they can give you is this. I'll keep the origin there. I'll keep the same person there. Suppose you have this, a curved line, an exponential. What does this imply? Well, this here means you are accelerating. Why does it mean that? Well, because it's not a constant graph. It's a curve, an exponential curve. It's going up exponentially. You are covering a rapid amount of ground in a certain amount of time. So the time is going up constantly, but not the amount of distance covered. So if you look here, this is not linear. Okay, 2 meters, 2 minutes, 4 meters, 3 minutes. Okay, there's a bit of a jump here with numbers. That's acceleration. So that's that. That's the displacement time graph. Let me move on to, let's say, a velocity time graph. So that's all really they can give you in a displacement time graph. That's what the typical scenarios are. Let's say velocity time graph. Suppose I'll give you this. Picture a person once again. Let's say the velocity is 1 meter per second. That's 0. What does this mean? This means you are moving at a constant velocity over a certain amount of time. Let's say 5 minutes. Okay. Flat line means the graph is at that particular value, which is 1 meter per second in this case. So constant velocity. Okay, the same velocity, same speed in a particular direction. That's constant velocity. Suppose I'll give you this. This means you are accelerating. You're accelerating because there's a change in velocity over time. By definition, acceleration, if you recall, is the change in velocity over time. I'll sometimes leave out the delta t at the delta at the bottom, in the denominator. That's okay, but I'll put it in this case just to illustrate what's happening. Time is changing, right here, and so is velocity. And so by definition, acceleration is that, purely that, change in velocity over time. So this means acceleration. Now, you can also have deceleration, which looks like this. That's deceleration. Okay, so someone's running really rapidly, that's acceleration. Someone's coming to a stop, that's deceleration. Okay, because the velocity is at, let's say, a particular value, then it drops all the way to 0, decelerates to 0. Okay, that's velocity time. Let's go to acceleration time. I should be putting an arrow here because acceleration is a vector. But anyway, once again, think of a person. Here's a flat line at, let's say, I don't know, 0.25 meters per second squared. And this is over, let's say, 20 minutes. This, once again, a flat line means it's constant at a particular value. Constant means it's fixed. It's the same. This is constant acceleration. Okay, if you apply the accelerator in a car at a constant rate, so it's increasing at a steady rate, that's constant acceleration. Now, suppose you have this is 0 here, let's say. If it's on the x-axis, the line, the trend, 0 acceleration here. If there's no acceleration, that means you're moving at constant velocity. Why? Well, because back to this formula. This formula only makes sense if there's a change in velocity. If there's no change in velocity, velocity is constant, then you have 0 acceleration. Okay, if I, let's say, leave my foot in a particular position in the car, on the accelerator pedal, I hold it there. That's constant velocity. If I then press down on it in a linear fashion, then that's acceleration. There's also deceleration, looks like this. Oops. Let me extend it down here to the negative axis, negative acceleration axis. Negative 0.25 meters per second squared. Suppose the graph is a line at negative 0.25 meters per second squared. That is deceleration. Deceleration because acceleration takes on a negative value. Negative means it's slowing down. And that's it. That's how you interpret displacement time, velocity time, and acceleration time graphs.